All right, good morning, everyone. Are you able to see my screen? I'm new to this Excel events, so awesome. There is a feature in here, so feel free to follow along. We'll have some kind of interactive scenarios. So feel free to jump in there. But thanks for joining me today. I'm Jayme. I work for Capital One's offensive security team. This talk is on hacker mindset, specifically applying troubleshooting to hacking problems. It's a pretty short talk. It's about 25 minutes or so. So we'll go ahead and get going. So as I said earlier, I'm Jayme from California, currently living in the DC area. I work on the Capital One offensive security team, specifically in the penetration testing team. In the past, I worked as a red team engineer, offensive security consultant, held a few systems admin, help desk style positions before that. And that really helped me hone in on a troubleshooting skill set. And that's really what I want to talk about today. We hear a lot about hacker mindset, and typically you hear think like the bad guy, but I believe that even more importantly than that is to think like hacking is a troubleshooting problem and to break it down into kind of its most basic pieces and troubleshoot each of those pieces independently. So this is all based on my personal experience. Works for me. Your mileage may vary, but I've had some good luck with it. First thing I want to clear up is hacking is not magic. It's not all exploits, 0 days, specialized tools. A lot of what we call hacking can be done with tools that are already on the operating system, tools that are already built into the applications we're looking at, or the functions of code that we're working within. There's not a lot to it typically in terms of like specialized exploits. Those do exist, but we're really looking more at the process flow, and what we can do with the tools that we have at our disposal. So before we get into things, I want to level set a couple of terms. First off, hacking and hacker. So what is a hacker? If you ask Google, the first result is that it's a person who uses computers to gain unauthorized access to data, or a criminal, right? I don't like that definition. It's pretty bad. To be clear, all hackers are not criminals. Some definitely are, but being a hacker or hacking does not necessarily mean you are a criminal or committing a crime. So let's go to the second result on Google. And this one actually works for me really well. It's a person who uses technical skill sets to overcome a challenge or a problem. And that brings to mind a lot of people besides just folks in black hoodies in their basement. It describes pretty much all of the IT operations and support people I've worked with over my career. So since we've defined hacking and we're going to be talking about troubleshooting, I want to level set that definition as well. There's a million bad definitions, a million good definitions, but it all comes down to one basic end goal, and that's tracking down and resolving faults or errors. This could be applied to hardware, software, network services, processes, even business processes. Troubleshooting is, sorry, I'm seeing that my audio is completely gone. Okay, cool. Thanks for that. So if hacking and troubleshooting are so similar in definition, using technical skills to fix a fault or error and overcoming a problem with technical skills, there should be a lot of overlap. And really there is. The difference here is a perspective shift. So we need to move our goal from finding the fault as on the left to finding the opportunity as on the right. Because both of these people in this scenario are trying to do the same thing, right? At the root of the problem, they're trying to access a database without credentials. One of them may be trying to access a database without credentials because they've been lost, locked out, taking over a system for another person, but the other person is trying to break into the system. The processes don't really change. You're using the same tools, you're using the same techniques most of the time. You're just coming at it from two different angles. So I think that perspective shifting is really essential. Redefining a hacking scenario as a technical problem is where you start being able to troubleshoot that problem and look at it less as this really daunting thing. Like up at the top here, we've got vulnerability is being described. So web content system will execute PHP code if you're able to upload it through this upload theme element function or the admin panel. That's a lot of information, and that doesn't really help you define what the problem is that you're trying to solve, right? The root of the issue is you need to find a way to log into the admin panel. The requirement, I need the admin password. So if we shift it to more of a support issue or a troubleshooting issue, we're looking at this vulnerability, the beginning of it at least, as a user's lost their password to a website. And there's a lot of things we can do from that. If somebody comes to you and says, I don't have my password to get in, you immediately start thinking of alternatives, right? Maybe looking for another user account that's able to log in, looking for a log or a recording of those credentials somewhere, looking for a way to bypass it or to reset. And from there, that helps you further your way through the vulnerability that's described up at the top. So I tend to use 3 different types of troubleshooting in my day-to-day work. The first is workflow troubleshooting, and this is following proven logical steps to rule out possible faults or possible issues and move on to the next one. This tends to be easier for people that are newer to support. You see this a lot when you call into like a help desk. That's when they'll tell you, okay, restart your computer, restart the application. Have you tried resetting your password? Things like that that might actually frustrate you because it seems like, why would I call into you if I hadn't done these things already? But really, it's following a workflow until you stumble upon something that's not as it should be, and you can start troubleshooting or fixing that piece. The second is Socratic questioning. By asking basic questions that build upon each other, as if you didn't understand the context or the depth of the situation or have any sort of background knowledge, it helps the person that you're asking the question uncover some deficiencies in thinking or uncover some assumptions that they may be skipping past. And finally, rubber ducky debugging. This concept is to explain the problem to an inanimate object that is incapable of context or understanding. So if you're explaining to a literal rubber ducky, it can't assume that you've done things. It can't assume that you've started at a certain place and have moved on from there and have already troubleshot something. So you have to really get back to basics and explain in great detail what you've done and what you're attempting to accomplish. So just a couple of samples here. This is an example of workflow troubleshooting. Maybe a little bit difficult to see, but essentially you start out with a problem in the green, which is the computer doesn't work. And you go through every piece of what could possibly be wrong from the most basic to the most advanced. And this might not even go basic enough, right? We can start off with, is the computer plugged in? If no, plug in the computer. If yes, you go to the next step. Is it turned on? Is the power button functioning? Things like that. You can go further. Does the building have power? Right? Is the power company online and working? But typically we'll start somewhere here, and eventually you're going to rule out enough where you have an idea of what's going on and what needs to happen to resolve the problem. This is a slightly more advanced version of workflow troubleshooting. It's very similar, except a problem like web pages don't load. That could be a number of independent systems. So yes, we're still going to follow the workflow, but you have to consider other things. You have to look at the local computer, the network and all of its components, network services, right? DHCP, DNS, routing, and each of those independent systems may have their own troubleshooting workflow. So it's not necessarily as easy as going through, finding where you reach one of the results, the red results, and then saying that's it. You may have to go into another workflow and start troubleshooting that. And finally, some of you are probably as guilty of this as I am. That's just putting a bunch of debug statements throughout your code and seeing where it fails. This is a form of workflow troubleshooting too. You're putting like these kind of pseudo breakpoints throughout your code, and you're looking to see where it stops. So for instance, if you're expecting this set headers message to appear on your screen, and the last thing you see before it crashes is entered for loop, you know that somewhere in between where those two messages are in code, that's probably where you want to start troubleshooting. And yet it is always DNS. Next up is rubber ducky debugging. you start by stating the problem and then stating everything you know about the problem or things that you've tried so far. A lot of times this acts as kind of like a one-person brainstorming session. And the answer tends to become clear as you're explaining everything you've done, because your mind will automatically start filling in some gaps and saying, well, if you did this, did you actually do this? Wait, I didn't do that. Let me go back and try that. If any of you have taken the Offensive Security Certified Professional, the OSCP certification, this is something they use quite often. If you ask a question about a host that you're working on, they'll give you two responses. One of them is try harder, which we all know and love. The other is tell me about the system you're working on. And when I was taking the OSCP back in 2016, whenever they said, tell me about the system you're working on, and I would start typing out everything I had done, everything I know, everything I've tried, 9 times out of 10, I would remember something or think of something that I hadn't tried yet and be able to find the answer to my problem. Socratic questioning goes the other way. So Socrates believed that asking probing questions would help a student more fully understand the problem. And if the asker was to play dumb, the student had to answer questions that they might not think of or might be making assumptions about. So it's the opposite of rubber ducky debugging. Instead of over-explaining everything, you question and answer everything you can. And I won't go through all of these, but you can see here, you're going back as far as like, if your backups aren't completing, have you installed the backup software? Is there a tape drive attached? Does it have a tape in it? Is the tape formatted, right? You're going back very basic, and it's sometimes frustrating when you're the recipient of these questions because it seems very obvious that you've already done these things, but it really focuses on things you may not have seen or assumptions you may have made. So this should be getting into more of the fun stuff now. We're going to talk about a few real hacking scenarios. I've reframed them all as kind of trouble tickets that would come into a support desk. And by applying some basic troubleshooting logic, no specialized hacking tools, we'll see how to overcome these problems. So feel free to type out what you do in chat if you'd like to play along with things, with these things. There's usually different ways to accomplish the same goal. So the goal that I come up with or the result I come up with may be different than what you come up with. They're probably both valid. So in this first scenario, we have a solo systems administrator, only sysadmin for a company. They have a laptop from the old admin who left very suddenly. No documentation, no passwords were left behind. Basically, they're locked out of the system that they were hired to manage. And spoiler alert, this was me starting a job about 10 or 15 years ago. It's an actual scenario, and we'll go through some of the troubleshooting steps. So this honestly shouldn't be a problem because we know how to troubleshoot system lockouts. And we have a lot of information here that we can use to determine what our next step should be or help us with our troubleshooting. So a couple things we know. There's 2 types of accounts, local and domain accounts, right? We don't know what the domain accounts are because we're locked out of the domain. We do know that one common local account among almost all Windows systems, by default at least, is administrator. So we have a place to start. We don't know passwords, but we do know that there's a lot of common variations that folks will use for the admin password. You can use season and year, spring 2021, password 1, the company name, but those are guesses, right? It's not a fact. And we also have to consider password complexity on the domain. We may end up typing all of these passwords out and realize it doesn't actually meet the complexity policy, and we're never gonna get in. But we do know the laptop is not encrypted. And we do know that in terms of access rules, local admins can read all files on a system or take ownership of all files on a system. So if we focus on a couple of things there, we know there's a local admin, probably called administrator. We know the laptop's unencrypted, which means we can mount it or boot from another disk without typing in a password. And we know that if we have the admin password, we can enumerate the entire system, all of the underlying files and folders, and maybe find either clues or actual passwords. So let's take this and develop an actual plan. We can boot the laptop from a rescue disk. There's a number of tools out there that let you boot a Windows system from a disk. wipe out the administrator password or reset the administrator password, log in as that administrator, and then we can try to escalate privileges. We can try to find domain passwords. We can try to find files that have hard-coded passwords in it. We can try to find other clues that might lead us to that. We can even use something like Mimikatz or other tools to either dump password hashes and crack those, or try to find actual clear text passwords. So that's exactly what ended up happening. After resetting the password, logging in, we found a script that had a backup exec service account and a backup exec service account password from a few years ago. Well, that user is usually domain admin or some very high level of domain access. And using an older password, we can try incrementing it. If the password is back them up 2018 and it's 2021, we can try incrementing the year on that password. And that's ultimately what ended up happening. Create a new domain account and we're good to go. So this looks like a lot of troubleshooting tasks, but there are hacking equivalents. Gaining an initial access foothold is as easy as resetting administrator passwords, right? And that's a troubleshooting task. Performing on-box recon enumeration, it's the same thing as doing file recovery. If you're going through searching files, looking for the right one, looking what's important, same type of task. Escalating privileges, going in and updating if it's not working, that's failed, that's the same thing. We're opening up a script, we're looking for credentials, and we're modifying those credentials. In this case, we're using an else login to a domain controller, and then establish persistence, which in this case is just creating a new account. So we'll go through a couple more. In this scenario, we have a server in a data center that's crashed, operating system has become damaged, and a lot of common commands no longer run. So we need to take this database and move it to a recovery server, but things that we would typically use, commands like scp, ftp, even copy, are no longer working. We do know that there's a Python script that's running that's taking these backups and spitting out a SHA-256 hash. So we know that Python's working. We know that the cron job is still working that's running Python. And we know that the backup that it's taken most recently is valid because the hash matches the expected hash. And here's just a screenshot of what it looks like when you try to run any of those common commands. So scp, you get a seg fault. FTP, you get an exec format error. So very damaged server. But the small amount of info we have on the last few slides actually gives us a decent amount to work with. We do know some commands work, but that common file transfer commands don't work. Right? We know that networking is intact. We're able to SSH into the host. We're able to get the shell. We're able to run things like PS and see the Python process is still running. We're able to see the Python process is still outputting hashes. So we're able to see that works, and that's in good shape. So we can start using the Socratic process to ask all of the questions that maybe we should be asking ourselves, but have skipped because we're making assumptions. And I won't go over all of these, but you're starting with a problem statement. If I need to copy this file across the network, that's the most basic piece of this problem, right? But we can go through, can we use FTP or FTP? No, they're not working. Are other commands working? Yes, some commands are working, right? So we're asking all of these very basic questions, which helps lead us to something that might be really untraditional, but will actually help us in this situation. In this case, we find out that base 64 is working, bash is working, and we have the dev TCP device. So we can actually send the 64 encoded application, backup over the network to the recovery server, decode it, and get our backup without using any traditional file movement commands or file transfer commands. So how does this relate to hacking at all? Well, when you're transferring files from a damaged machine with potentially damaged binaries, you're not really exhibiting skills that a hacker trying to exfiltrate data on a restricted system would be exhibiting, right? If you work on a host that's very locked down, you may not have access to things like SCP or FTP. You may have to get creative. These days, when you compromise a host, a lot of times it's going to be like a Docker container, or it's some other workload that has a really restricted set of commands. You're not necessarily going to be able to hop on a system and run curl and wget and FTP and the things that are going to make your life really easy. You're sometimes going to have to work past those system restrictions to exfiltrate the data or to pull files on the box. So this is the last scenario. This is something I've actually run into variations of a couple of times. Essentially what's happening is a script that should be running has stopped. It's a cron job. It stopped running successfully. So the job is still running, but it's failing to complete. We know it uses LDAP, uses MySQL, and it's synchronizing data every so often. And this is kind of a strange one because three files. So there's a config file, and the config file is the script takes all of its information, things like destination servers, ports, protocol versions, things like that. There's a credential file, which nobody has access to except for the user running the script. And then there's the script itself, which is doing all of the actual heavy lifting and the movement and the processes. The systems admin account, which we have, we're able to log into the system. We're able to run a limited set of system admin tools, and we're able to run, edit and read, write, and modify the config file, but we can't look at the credential file. We can't look at the script itself, but we need to get that password to further troubleshoot this issue. So we know a few important things. We know there's two users. We know each one has a different set of permissions. We know the account that we can access and log in with can't read the file we need, but it can read some other files. And it does have pseudo privileges to run administrative tools on the system. We also know the technologies in use include MySQL and LDAP. LDAP is important because it's not LDAPs with the S at the end. So this is not an encrypted version of LDAP, meaning anything that's sent over the wire is going to be in plain text. Some of you might be able to see where this is going. So if we look at the config file, we see we have read, write, and execute permissions, but we don't have permissions to read, write, or execute the credential file or the order stats, the actual script file. But when we look at the config file, we can see the server is pointing to LDAP01. We can modify this. Anytime that you have a situation where you can fully modify a file that's part of the scenario you're trying to solve, the hacking scenario, you should really investigate that and see what you can do with that config file. If you can write and make jizz, you don't necessarily have to attack the script itself if you can attack the supporting files. So this is really good. We can control the LDAP server. And if we can control it, we can change it. So we can abuse those access rights by just changing the destination that this script is sending information to ourselves, right? And if we're able to then run a server or a network service that can catch that information as it comes across during the next attempted cron job, we can probably catch the authentication piece. So that's exactly what we do. We change the server, we run netcat on port 389, and there it is. There's the administrator account, a question mark separating the account name from the password, and now we've got the credentials we need. But this is also a systems admin with some pseudo rights. So what if that doesn't work? What if you don't have access to modify the actual config file? Well, there's another way you can go about it. We can abuse the protocol itself. We mentioned that LDAP is plain text. We have access to run admin tools such as TCP dump. So by running TCP dump, filtering on port 389, we can create a PCAP that has the plain text username and password inside of it. And we don't need access to any of those files. We just need access to run TCP dump. So just to recap what we've talked about, hacking isn't magic. Follow process over tooling, break things down into smaller problems, and then restate the problem you're actually trying to work on. It's really easy to get lost in the weeds with hacking. It's really easy to look at a problem and realize that this is a really significant, really difficult to understand vulnerability. There's a lot to it, but break it down until it makes sense at the very basic levels. Explain the problem aloud to yourself, a coworker, a rubber ducky, whatever makes the most sense. When I'm working on a difficult hacking problem, oftentimes I'll talk to myself and I'll just talk it out to myself aloud because it forces me to explain it, forces me to uncover things I might have missed before. And then if you're stumped, just think about how the process works. The great thing about hacking is if you understand technology and you can figure out a general idea of the workflow of what you're looking at, you don't really have to know the application all that well. Um, as penetration testers, we go into pen tests not really knowing what we're going to find all of the time. Sometimes have a vague idea, but we might be looking at software, open source software, closed source software, whatever, that we've never encountered before. But if you can figure out